Cisco Certified Network Associate, and this is first day of our this course. So whenever it comes to network, we always take the name of Cisco first. Although there are multiple companies in the market like Juniper, Huawei, Alcatel, Nokia, and so many. I haven't taken their name, but still there are a lot of companies in the market. But when it comes to networking, we start with Cisco networking because concepts are the same in all of them. So obviously we can choose one of them, and then if required we can change the syntax and apply in the remaining. Okay, so let's understand the network first, that what is a network. So if you go to the normal scenario, okay, so let's take this is your home router. Okay, whenever you are taking the connection from any of the ISP, then it's like that. This is an ISP, it is giving you a connection via modem, and then you are is installing a router in your home like this, and then this router can be connected via multiple laptop. If you are having multiple laptops, TV, or mobile phones, or printer, right? You can have printer as well in your home. They can also be connected with the same router. This is called a router. So first, let's understand from the ISP. Okay. So ISP, the full form of the ISP is Internet Service Provider. What it does actually, these are the companies which provides internet. Like if we talk about India, then there are multiple ISPs like Airtel, right? Jio, Vodafone, and so many. If you want to talk about the US, then they are having AT&T or Verizon, right? So such type of service providers are there. The job of them is to provide internet to home or anyone. They are just internet provider. If there is office, there is a requirement at the office, then obviously they will provide an internet with the comparatively larger bandwidth, because the office there are a lot of users, a lot of computers, and they need very high bandwidth. So in that case they are providing the very high bandwidth. But in the home, obviously we need 2 Mbps, 10 Mbps, 100 Mbps, or 1 Gbps as per the requirement, because in some of the houses there, they just need very much bandwidth, right? So that's what it is doing. Next thing is our modem. What is modem does actually? This is the full form of them that can be said as modulator and demodulator. Actually, in the older scenarios, these were highly used, modulator and demodulator. So I can just write like that. Okay. So what was happening? There was a coming analog line, and for the conversion of analog to digital, we used to use this modem, or this is called a box to convert the line. So right now in the modern scenarios, this has been skipped, and directly ISP is giving optical fiber, and their routers are also fiber capable, and the optical fiber is directly terminated over here. And in some of the old technologies we are still using the modem, and so in some cases we are also still using the dial-up connection. So this is just to provide an internet connection to our home router. That's it. So once we reach our router, from the router we need a connectivity to the computer. Okay, so if we take about this IP, right, this IP, if you focus on this one, their IP address is starting with 192.168.1, and this last is changing. Oh, this is one as well, so let me change this to 2. Normally it should be 2, this is 3 or 4, right? So that's how we give the IP. Or normally what is happening, there's some automatic configuration. We normally use DHCP for that one. Don't worry, I will come in the coming session. I will totally explain that how DHCP works. But till now, just to overview to understand that this DHCP provides an automatic IP to each of the computer. If you connect a new mobile phone to this one, right? There's be some Wi-Fi connection, and it will be giving to the new IP to the this mobile phone. And now this is connected via our computer. So these IPs which are starting from 192, right? These are called the private IP. What are they called? They are called the private IP. So what are these actually private IPs? These private IPs are not used to communicate to the global world. यानी कि uh, they are not going to outside of this router. They are just confined to here only. If I just draw the boundary, let me change the color first, so it will be easy to identify. Okay, so if I make a boundary, it is somewhere, it is limited to here, right? This is your home. So this is not, in fact, I should not say home, that I should call it as a local premises. Okay, because it can be an office as well. So I should say that this is a local premises. Okay, so in that case, these private IPs addresses are significant to this area only. And when they are going to the global world, what is happening? These private IPs are mapped in this public IP. This is public IP. You see that this is starting with the 82 or something like that, right? So these are the public IP, and these public IP are unique in the internet, and these are normally assigned by the any authority. Normally it is done by the INA. So INA provides a public IP to everybody, and obviously these IP addresses are not got free. You have to buy them. You pay some amount and the INA gives this IP. It's like you buy a hosting service or a website. So they are giving a IP address to your hosting server, and then you just reach them. So don't worry, I will just explain slowly. We have a long time to spend with us. Okay, so as of now, just understand there are two types of IPs: public IP and the private IP. So private IPs which are just confined in that some local area, and the public IP which are going outside in the global world. So this, whatever we call this as local premise, this is actually a local area. So what we call this as local area, we call it as a local area network, right? Because this is local, so we call it as a local area network. And that you might have listened LAN. So that is called a local area network. Okay. Now, next thing, obviously, if you take a name of LAN, then a mind, automatically it creates in your mind that what is WAN. If you have heard these terminologies, if not, then just listen it. This is called a wide area network. Wide area network. What is this wide area network? Area network is combination of multiple LAN, right? If you talk about, there will be multiple LAN, right? So how they will be obviously connected, right? So they just form connection to each other, and they just form a WAN. There is also terminologies as MAN, that is called as a metropolitan area network, but that is not too much used in this scenario. There's nothing. It's like saying that if you have one home, right, or one building, then that is called as a, if you have multi-story building, then that is a LAN. If you have, multiple multi-story buildings, like if you take a society or something like that, right? So this is a little larger than this one. This is called MAN. And if it goes to the very large network, or we can say very large, so that is called as a WAN. So this is the concept of LAN, MAN, and WAN. Okay. So let's understand the concept of router and switch. What is actually a router and what is a switch? So, right, this heard this, we are having this router here, right? So what is actually router? What is its job? So router is a device, just listen carefully, that oh, a router is a device which is used to communicate different networks. What it does, it makes the communication possible between the different networks. How different networks? If you go in the previous scenario, then what is happening? This is a local area network. It is something network starting with 192, and this is another network starting with 82, or this is outside network, right? This is a local area network, and this is something an outside of network. So this router makes it possible to make communication between the outside of network and the inside of network. Correct. So now a question arising in the mind, that what is a network actually, right? It you might have been in mind. So what is a network? Network is the connection of two or more hosts. Here you have to be cautious. I can have said as a computer, but it is not good idea to say it as a computer or a laptop, because this is our, it can be a mobile phone, it can be a laptop or computer, it can be TV, it can be a printer, right? Because we are having a smart TV as well, and they are also connected. So it's better to use the word hosts. So whenever there are two or more hosts connected, they form a network. Going to previous one, what is a switch? Switch is the device which makes a connection possible. So it's like if you have gone through the switch, it is something like that. They are having multiple ports over there, right? Normally it's coming as 24 port switch, right? Or 50 port switch. So there are different combinations of the ports switch are coming. So the main job of the switch is to provide the communication, because they are having the multiple ports. Whatever the traffic or data you are giving, that replicates in all of them. You just give feed here or data here, and you can get output in all of them everywhere. So that is the job of switch. So that is switch connects the devices. So that's job of the switches. We can say that is a connects the devices. So that is the job of switch. Okay. What is the host? So host can be any our networking device. It can have NIC or network interface card, network device. Okay, so that's how it is happening. These are the basic devices which are used in the networking. So if you take a real world scenario, what how the communication is happening from internet to server. Suppose you are taking, or you are list watching in the YouTube, watching YouTube. So what is happening? I have prepared a video in my computer. I have uploaded it. How this goes to a router. Now from the router it is connected via ISP, and ISP might have been connected from the server of the Google, right? This might be a Google server, and in the server this video is stored. This is taking some space in. These are the, might be we are having the another device for the storage, but obviously there will be some space to store these data. So once this video is stored, now if you want to watch this streaming, this you just request that I want to listen it, and it starts streaming here. So this is called an upload because I am sending it to server. So this is called uploading. And now you're watching this YouTube video. So that is called a download. Okay, so that is a downloading, or that is also we can call it as a streaming because this is a type of downloading a data. So that's how it is happening. If you talk about the suppose you are sending a WhatsApp message, then what is happening? Suppose you send a WhatsApp message, it is started from your mobile phone. Obviously your mobile phone will be connected from this router. It goes to the router, it goes to, because there will be some other server for the WhatsApp, something like that, and this ISP will be connected via this as well, WhatsApp server, right? Or you can take any of the device, because without server there is no communication. So now this traffic is going to the server, and now from the server it knows that okay, I have to send this device, and now it sends to other one or another mobile phone. Wherever you want, you can just access that data. So obviously there was a use of servers. That's how we communicate. So what is actually an internet? That is a very important question. We have learned this ISP, right? We have known that we are having internet service provider, but actually, what is an internet? So, what was happening initially when the, how this internet came in the picture? Let me go to the history first, so that will make you clear understanding of that one. Initially, in the American defense, there was a unit as DARPA. So what they were doing, they were doing the research and development for connecting the computers. So they were quite happy, and they just connected all the computers of office, and they were able to send file or transfer data to each of them. So they are quite happy once their office was quite okay. But what was happened? There was one more office. Now their requirement was fulfilled over there. Now they want to communicate to the another office. So what they did, they just connect these two offices from each other. So now these are the lines, right? We have to dig cable over there, or you can use optical fiber cable for that one. So anyways, we have to connect via any of the thing we have. Right now we are having the microwave communication as well, or satellite communication as well. Any ways right now, but or in the older ways, obviously they use the cables to connect all these data. Okay, so what has happened after some days? Suppose the whole New York was connected because everybody was data hungry, and everybody was just quite aware, have taken the advantage or the benefit of these data transfer or quick data sending. So our whole city was just connected via each other. Once this city is done, now it comes to our country. Now one of the country want to connect to each other. So what happened, that big companies like initially it was right, because they have a huge investment from the connecting one country to another country. They need a lot of infrastructure, lot of money to lay these cables, or we also use submarine cables which are going under sea to connect one country to another country, right? If you search on the Google, you can see the submarine cable network. Just search the submarine cable network, it will show you, or I will just show you in just a few minutes. Okay, submarine cable network. So it will show you that how many networks we are having. They are the very high speed optical fiber. So initially at the in the old time, what was happening, that AT&T was providing the this. They were ready to provide this infrastructure, or they were able to invest such type of money. So they just lay the cable of this long from one country to another country. So whenever this one, there's a big countries, big companies, they invest large number of cables from one country to another country. So such type of the companies are called the tier 1 service provider, tier 1 ISP, because they have the very high optical fiber. They are also called as the ILD, international long distance cables. So or we sub call as a submarine cables. So but these big companies, they are always called as a tier one company. What happens after that one? Now this tier one company, they are not able to give internet to every customer of your city or every customer. So what they do, for easily reach to our country, they have a tie up with the a smaller vendor, and they are also type of the tier two internet provider and ISP. So they're smaller than that one. They just buy a lease line, they take a lease from that one, they use their cable, they pay some money to them because they are using their cables for the internet, and obviously you also pay some money to them. And in some cases, what is happening, these tier 2, even tier 2, they are providing some of the internet connection or to the big offices, or there wherever there is a huge revenue, or else what they can do, they can further outsource it to the tier 2 ISP. So now these tier 2 ISP are providing the internet connections. So internet is just nothing else that it is just connecting every network. We are having a small LAN here. We make a little connectivity. We created a MAN, and then now we have connected one country to another country. And obviously somewhere here, suppose this is a US, so Google has set up some server here. And now if you want to anything from the Japan, then what is happening, you are trying to reach from here to our this the Google server over here. Everything is now green. Let me take it red. So this is our Google server. Now you want to reach from Japan, you use these cables and you reach Google server. Google server responds whatever you have requested. You have requested any download of the file, you get it here, or you are watching YouTube videos, you can watch over here, or anything, because obviously Google is everything is not US, might be everything any server in the Singapore. Or now the companies are also so smart, they do not set up a server only in one country. They choose different geographic location, because if every traffic is coming to her, then definitely these bandwidth will be choked. So what they do, they just set up one server in Google in the US, then definitely they will set another server in the China or Europe or somewhere in between, so that the nearest user just go to the nearest server, and they save this bandwidth of the cable. They do not just use all the traffic of this uh, data, right? So let's just go understand our this tier 1 and tier 2 network. This uh, this is a big one right here. We are having the tier 1 networks, and they have just given to tier 2, and then we are having one more, that is a PSTN. They are the uh, they are called, I think, public switch telephone network. So they are also a type of uh, internet service provider, because they have just taken from the tier 3, right? Because these are PSTN. Earlier what was happening, these are the telephone networks older. So earlier we used to have this landline numbers, and that was communication was happening from phone to phone. But what happened, as because they're already having the cables, so they used their cable for the internet as well. So what they did, they took connection from the tier 3 ISP. So now their network is equipped with the internet. Now they further connected this internet what they have got to the lower subscriber whatever. So now they are using our modem or DSL, or they are using the dial-up connection to connect to the computers. And they are also establishing one, if you want wireless router, you can set up a Wi-Fi, and then you can connect to our over there. Correct. So that's how. And if we directly go to, suppose you have a optical fiber enabled uh, router. So directly optical fiber cable is connecting and terminating to the router, your home router, and now that is Wi-Fi enabled, and that is giving to Wi-Fi to your computer or your mobile phone. Or if you want to connect via cable, then you can use your laptop via connecting to the cable, because this is having some, I think, 4 to 6 ports depending on the type of router you have purchased. Normally they are provided by the service provider, but if you want, you can use your own router as well, because in some cases they do not provide, or they charge some extra money for this router. So it depends on your choice, that how much you have invested, or which type of service provider you have taken. So that is quite okay, I think. We can take one more example of the office. I think that will be better. So let me take one example for the office, right? So suppose we are having one ISP, and here we are having the huge routers, and after that one we are having a switch, and from that switch we are having the multiple computers connected on the office. So one, two, three, four, or five. There are a lot of connection over there, or even if they want to extend it, they just create uh, a wireless access point, and then our laptop, office laptop, can be connected via Wi-Fi as well. So that's how you see that from the router they are coming to the switch. So don't worry, I will just explain everything step by step. I'm just giving you the overview that what is an internet, how actually devices are connected. That's it. We will just go more and more deep in the coming sessions. And my plan is to cover CCNA 20301 syllabus completely. Okay. So what is happening actually, because this is ISP and obviously this is our office network and they want some security as well. For that purpose, what they do actually, they put some firewall in between. So what it actually the firewall does, firewall tracks the traffic, it understand it, and then it permits or deny based on the rules whatever we have configured, right? Just mind the words. It is distinguish the traffic, not the computers that I have to block this computer. Not, it can distinguish the traffic, which type of traffic it is, from where it is coming, from where to it is going, which type of data they are using. So based on that one, it just classify that one, and based on the rules whatever we have defined in this firewall, it permits or allow the traffic. Suppose we have want to block the Facebook. So what we do that we just deny over here that if any data is coming from the Facebook or going to Facebook, just deny it. Do not allow it to cross it. Or this is just one way, because in the offices normally some of that you know bad website, or they think that this is not good or use, so they just block their website. So based on that one, they just block the traffic. But this is not a very optimal way. But the best thing is, or the purpose of the firewall is to stop the attack from the outside. What it does actually, it just blocks all the attempts to crack our network. If any unwanted hacker or any bad guy, he just want to access our network via telnet or SSH or anything he just want to do, or there's a bad website. We have some policies that if there is a new website and it has just 3 days, or it is a non-secure website, so there are different criteria that how can you block the traffic, or it is coming from the some FTP you want to block, or anything. It just depends on your choice. There are a lot of flexibilities available in the firewall. You can just block whatever you want, but just you have to be smart enough to configure the or this firewall. Okay, so let me go to over this first one where I was just writing the definition. So I just can write it here, the firewall as well. Okay, so what is the firewall? Firewall, it permits or deny traffic based on the defined rules. So whenever this was happening, and there was a time when there multiple uh, companies started, or multiple countries uh, started to connect each other. So what happened actually? This suppose this was our US. Here it was suppose UK. It was India somewhere, and it is China, or some other countries like Spain or Egypt There multiple countries. So obviously there were some companies over here who were just manufacturing the telecom equipments, or in short we say networking equipments. They are preparing their router and switches, and there this company, there also might be the same company working over here. It might be they are producing the same equipment, uh, but it might be the case that in the other country there might be some other company and they are e- producing the equipment of their own standard. So suppose this is company X, this is company Y, this is company Z, or this is company A, B. So what was happening in that case, these equipments or this router or switches, they were not compatible with each other, right? So when they try to communicate, suppose they have installed a router here and they have installed one router here, they were not able to communicate. So what was happening, that they suppose this XYZ company here, so XYZ company also need to be here. They were not able to communicate between each other. So for to solve this purpose, what happened, they introduced the OSI model. So what does this open OSI model does is just says that open system interconnect. Okay. So this was a standardization body. Okay. So they just provided some standard that how everybody should produce their equipments, or they should able to communicate with each other. So that was just given a idea that if you produce with this type of traffic or this type of standard, you will be able to communicate with each other. So this was very important to uh, provide a cross vendor communication or cross country. In fact, yeah, that's cross vendor communication. I think this is a good thing, because they were having the different companies and they were producing according to their standard and according to their understanding. But with this OSI model, everybody was just creating the same platform, and now these equipments were able to communicate with each other, and the communication was very easy. So what I will do, I will just stop here, and I will explain this OSI model. We are having the layers in the OSI model. I will explain in the next video with the more detail, because I don't want to make the video so long so that you just lose interest and it does nothing goes in your mind, because this is very it easy to listen, but obviously it's a little complicated. If you don't listen carefully, then nothing comes in your mind. So my plan is to uh, prepare a video. Okay, prepare video, because why I'm doing this one, to save my time, because obviously I have some other assignments and I'm also working, so I cannot uh, take a live classes to you guys, because I create these videos anytime whenever I get free, and I just upload it in the YouTube. Okay, and you just watch them. And what's my plan, that every weekend or once in a week, uh, weekly or bi-weekly, whatever will be comfortable, we will take a live session on the weekends. So in that session, whatever we have discussed in the videos, so our my plan is to create a 2 to 3 hours session in a week. Okay, so you can watch them, and obviously if you watch them carefully, so you might have be having some doubts in your mind. Whenever we are having this bi-weekly live session, you can ask all the doubts to me, and I will sort it out. And it might be the case because I'm not smart enough and you may think beyond. Then if I'm not able to answer, I will just look for them, or I will go to the my seniors or experts on that one, that what they provide me, and I will get back to you that what is the solution of that one. So that's my plan. So now lot of guys were asking that what I'm going to cover. So obviously we have, you might have gone to our Cisco website. You can go to the Cisco certification and you can watch the syllabus of the CCNA associate level. So I'm going to cover the associate level entire syllabus. That's my plan. And obviously if we take, I think take 2 to 3 hours session in a week, So I think 30 to 40 hours, I think I would be able to cover the entire syllabus. So 40 hours means if I take 40 hours, then it will take around, I think, 20 weeks. 20 weeks will be very much. So I will be little shorter or summarize it. I think 20 hours will be more than sufficient, not more than that. Still, if I required, then I will increase this time duration. I will take it to 3.5, but I think 20 to 25 should be sufficient with that much. But if required, then obviously we can increase it, or some of the data we can cover in the our live session, because we are having the doubt clearing session. So this duration reduces, because whatever I am suggesting, that for the live classes that normally it's taking the 30 to 35 hours, because that is a lot of time is wasted in that, because guys are asking questions and we just try to explain them. So our live session is excluded, so we might achieve in the 2025, but still, if not required, I have to cover it all. It does not matter how long it takes, but quickly as well, because I don't want you guys to just wait to finish it and then you go further. And still, if you feel any question, we have the group as well, and the group name is, I think, CCNA VIP in the Facebook. You can go to the facebook.com groups.com something here, and groups, then we are having the CCNA VIP, and all the information I will be posting at that Facebook group. Okay, so that's okay. In the next session, we will uh, discuss about the OSI model and the 7 layers, how we use it, what are the use of or the functions of the different layers. Okay, so till that, bye bye, and see you in the next video.